So welcome to this class on financial performance measurement. This is part 6 of the classes on financial performance measurement. Here we'll start talking about dynamic indicators in detail, and in particular we'll focus on dynamic payback and net present value. So this class will be structured as follows. First of all, we'll talk about the different types of dynamic indicators, and then we'll focus on dynamic payback and on net present value. So we have 4 main types of dynamic indicators for financial measurement that we'll analyze in this class and in the next class. The first one is dynamic payback period. The dynamic payback period is equivalent to the payback period that we have already analyzed in previous classes, but the difference is that this time the cash flows are discounted. So we are looking at the times cash flows employed to recover the initial investment, but this time we are looking at discounted cash flows. Then we'll have net present value. The net present value is the present value of all the cash flow generated by an investment, net of the initial investment required by the project, and can be applied to measure the value of both total investment, so the value created by the project for all the investors, and the value for the shareholders. So the value, in this case we'll have the net present value of equity, and in this case the net present value will discount only the cash flow to shareholders, and the value created is for the shareholders. Then in the next class we'll look at the internal rate of return. The internal rate of return, as we'll see, is the return of a project, so it's a very useful and complete indication about the return of a project. And also in this case we can look at the return of the total investment made by all the investors, or the return only on the investment of equities, or the investment made by shareholders. and then we leave the modified IRR, that is basically very similar to the IRR, but in this case we correct for one particular aspect, that is the assumption about the investment rate during the life of the project. So in the basic IRR formulation, we'll see that the assumption is that the cash flows generated by a project are invested at the IRR over the entire life of the project. These assumptions sometimes can be not so realistic, so we can apply a different method, that is modified IRR, that is more flexible in this sense, and again the modified IRR can refer to both the total investment and the equity investment. And finally we have the net present value ratio. Net present value ratio is a ratio between the net present value of a project and the initial investment. This is required, as we'll see, when you will have to rank different projects depending on their value creation, and the capital budgeting constraints, and the specific projects have different initial sizes and require different initial investment. In this case, if we just look at the NPV, we can make errors in the selections of the project, so we have to use this corrected ratio that is, in this case, better suited for this kind of situations. Okay, so after this general view on dynamic indicators we'll analyze in this class, we can now pass to the first one, that is dynamic payback. Here we find the formula of dynamic payback, but before looking at the formula, I want just to recall for a moment the meaning of this indicator. So as for the payback period, the dynamic payback is saying what is the period the cash flows of investment take to recover the initial investment made for the project. And in this case, the dynamic payback has exactly same meaning, but with a technical difference. And the technical difference is that we are not looking at the nominal cash flows, but we are looking at discounted cash flows. So it's the sum of the discounted cash flow that is to equal the initial investment. And this appears clearly in the formula that is in the slide. So here you find the summation for t going from 0 to p. 0 is the initial investment, p is the payback period, and t is the timing. So here you have the operating cash flows at time t that are multiplied by the relative discount factor that, as you remember, is calculated as 1 divided by 1 plus r at the power of t, where r is the discount rate. So the idea is that the project reaches the payback period, so P, when the summation of all these present values of operating cash flows is equal or greater than 0. So in the moment T, where the sum of all the cash flows accumulated until T have reached 0 or have become greater than 0, is our payback period. And as we have already discussed in the previous classes, the payback, given its meaning, represents a measure of risk of the project, because we prefer in general projects that recover the initial investment before rather than later. So the use of payback period is a risk indicator that will be discussed also in the following classes. But we have to remember that anyhow, even though we are correcting for the discounted value of operating cash flows, the payback periods, even in the dynamic version, still keeps the important limitations that we observed for the static payback. And particularly, the main limitation of the dynamic payback period is that once that the payback period has been reached, the payback period does not consider all the cash flows that follow the payback period. And this is evident in the formula. You see that summation goes up to P, but the life of the project will be longer than P, and so all what happens after time P is does not concern the calculation of the payback. So if after time P there are relevant cash flows that could affect the decision to invest or not to invest in this project, they are not taken into consideration in the calculation of the payback, even in the dynamic version that is represented in this slide. So we have to remember that dynamic payback is an indicator, an empirical indicator of the timing of the cash flow and the risk of the project, but it cannot be considered as an objective or unique indicators to assess the economic convenience of a project. Okay, so after having discussed the dynamic payback, we can now pass to the most important dynamic indicators, that is the net present value, that is abbreviated as NPV. So the NPV is the most used indicators for project evaluation, and is also the most correct one for the reasons we'll discuss in a moment. And it's characterized by several specific characteristics that differentiate these indicators from other potential dynamic indicators. So first of all, the net present value is based upon the appropriate cash flows. Appropriate means that the NPV can be calculated both in the perspective of total investment and the equity investment. So the relevant cash flow clearly will change depending on which perspective we are taking in the calculation of the NPV. And the cash flows are calculated for the whole life of the project. So the NPV is an indicator that accounts for the benefits that the project generates over its entire life. So for these reasons, it is a complete and comprehensive indicator of the value created by a project over its entire lifespan. Second, is a clear measure of the surplus generated by an investment. In fact, it compares the present value of the inflows with the present value of the outflows, And if the inflows are higher than, if the present value of the inflows is higher than the present value of the outflows, the NPV will be positive, signaling that there is a surplus generated for the investor. On the contrary, if the present value of the inflow is lower than the present value of the outflow, we'll have a negative NPV that is signaling that the project is destroying value. For this reason, the NPV is the main indicators of a project's financial merit, and in particular, according to the logic that we were discussing 1 second ago, it provides a very clear and straightforward rule for investment. In fact, if NPV is higher than 0, if it's positive, this means that it's creating a surplus for investors. This means that it's generating value, added value for the investor. So this means that the project should be accepted. So the rule is that if NPV is higher than 0, the project is convenient and should be accepted. On the contrary, if the NPV is negative, this means, as we were saying before, that the present value of inflows is lower than the present value of the outflows, so the project is destroying value for the investors, and therefore the project should not be accepted. So the rule also implies that if the NPV is negative, the project is not convenient, and the project should be not accepted. In the theoretical situation where the NPV is equal to 0, this means that the present value of the inflows equals the present value of the outflows. So in this theoretical situation that, however, is quite unlikely, the investors should be indifferent between investing or not investing in the project, and so the rule does not say anything in particular about whether the project should be realized or not. And given all these characteristics of NPV, the NPV explains in the end the value of an investment project. So the number that we get by calculating the NPV, in theory, if well calculated and if based on sound assumptions, represent exactly the value that the project creates for the investor. So it's really a measure of the value created by an investment. Clearly, I specify that this is true under the conditions that we made correct assumptions. But assumptions, however, refer to the future, so assumptions could change in the life of the project. And therefore, we'll see in the next part about risk analysis that indeed you will run some kind of sensitivity analysis on the value of the project. So let's say that the first value that you get when you calculate the NPV is represent a first idea about the value of the project, but this value could change depending on the different assumptions that we can make. So we'll see that in the risk analysis part, we can run a sensitivity analysis that sees how the NPV changes when we change some critical assumptions that we made in the calculation of the project. But so far, the net present value is the clearer and most correct and those most often used indicators for a project value. So we see that calculating net present value involves 3 different steps. The first step is estimate the cash flows. As we have said in the previous slide, the calculation, the NPV is an indicator based on the cash flows generated by a project over its entire lifespan. So the first thing that we have to do, based on the pro forma financial statement, in particular on the cash flow statement that we analyzed in previous classes, we have to estimate the relevant cash flows of the project for its entire life. So this will represent the basis for the calculation of NPV. And again, if the NPV is calculated in the perspective of all the investors, so we are calculating the NPV for total investment, the cash flows will be the operating cash flows, whereas if we want to calculate the NPV for the equity investors, we will calculate, we will use the cash flows to equity. So we'll see this difference in the next slides. Once that we have calculated the future cash flows, we have to apply an appropriate discount rate. In fact, we have to consider the effect on time value. At this point, we know that different cash flows have a different value depending on the timing of their availability. So depending on the timing of their availability, their present value will be different, ceteris paribus. And so in order to make all the cash flows comparable, we have to discount them to the present moment, conventionally times 0. In order to do that, we need a discount rate. So we will have to estimate the appropriate discount rate for a project. At this point, we know that the discount rate depends on the risk on the project and can be calculated in different ways. One way is to use the opportunity cost of capital that, as we already mentioned, is the rate of return that I would expect from a project having the same risk of the project I'm evaluating. Or I could use the cost of capital, in particular in the form of the weighted average cost of capital, that, as we have seen, is the average cost of capital of the different financing sources that I'm using for this project. Once that I have defined what the discount rate is and I have calculated the present value of each of the cash flows that I have estimated, at this point I can just sum all the present value of the cash flows, and in this moment, in this way, I will get the net present value of a project. This procedure can be formally observed in the slide that is here, where we report the formula for the calculation net present value. So as you can see here, the NPV is calculating as the sum for t going from 0 to n, where 0 is the present moment, the moment of the investment. N is the final year in the life of the project, and T is the timing of the cash flows. And here we have the operating cash flow at time T divided by 1 plus R, that is the discount rate, raised to T, that again is the timing of the cash flow. So basically we are multiplying the operating cash flows at time T times 1 divided 1 plus R at the power of T, that is the discount factor for a cash flow at time T. So we are basically doing what we have said before in a qualitative way. So we are just estimating all the cash flows for all the times T in the life of the project from year 0 to year n, so where n represents the end of the life of the project. Once that we have defined these cash flows, we are discounting them using the formula for discounting that we have already seen in the previous classes, and using the appropriate discount rate. And in this way, we get the sum of all the present values that in the end is the NPV. That, as we have said before, can be equal to 0, can be higher and lower to 0, with the implications that we have already discussed for the decisions about the project. In particular, this NPV is discounting operating cash flow. So this is the NPV for total investment. So it's accounting for the value created for all the investors in the project without distinguish between creditors and shareholders. So in order to understand better how the calculation of NPV works, we can look at an example. So here in this table we have an example that has two main objectives. The first one is to show how the calculation of NPV works in practice, and the second one is to show how the choice of different discount rates impacts on the results that we get in terms of NPV, and how this impacts also on the decision that we make on the project. So in this table, we can observe that in the first column on the left, we have the year. So the project has a life of 5 years. And year 0, we make the initial investment, so the present moment. The second column reports the operating cash flows. So we have an initial investment of minus 10,000. Then we have a positive cash flow at time 1 of 3,500, the positive cash flow 3,000 at year 2, a negative cash flow of minus 1,000 in year 3, and finally a positive cash flow of 4,000 at year 4, and a positive cash flow of 5,000 at year 5. And in the third column, we have calculated the discount factor for each of these cash flows, assuming that the appropriate discount rate is equal to 10%. So here we found the discount factor that is applied to each of the cash flows depending on its timing. So, and as we know from previous classes, the discount factor decreases over time as the power of the discount factor increases, and this is a denominator, so this means that the discount factor is going to decrease when t increases. At this point, we are under the assumption that the discount rate is equal to 10%. We are calculating the present value of each of the cash flows. So clearly, the present value of the initial investment, as it's made here, it's already a present value, and so it's minus 10,000. And in fact, the discount factor is equal to 1. And then we have here the different present values of all the remaining cash flows from year 1 to year 5 that are calculated by multiplying the predicted operating cash flows time the discount factor at the relative timing. And in this way, we get the present values for the cash flows from year 1 to year 5. And at this point, we can go with the third step of the calculation of the NPV, that is the sum of all the present values that gives us a result of NPV of 747 that is positive, and thus suggests that the project is convenient and therefore should be realized. At this point, we have a new column where we recalculate all the discount factor, this time under a different assumption about the discount rate. In particular, we are assuming that the discount rate is equal to the 15%. And as we could expect, for any given year in the life of the project, now the discount factor will be lower because the discount factor is negatively related to the discount rate. So if the discount rate has passed from 10% to 15%, the discount factor as consequence is decreased as compared to the relative discount factor when we had this R equal to 10%. So now we can multiply the same operating cash flows times the new discount factor. We refer to the same operating cash flows because the choice of a different discount rate clearly does not affect at all our estimation of the operating cash flows. It's only a matter that concerns the choice of the discount factor. So we have no implication for the cash flows. So we are multiplying here the previous cash flows times the new discount factor. In this way, we are obtaining a new present value for the operating cash flows that clearly will be lower than the present values that we obtained in the previous case with the discount rate equal to 10%. So if we sum up the new cash flows, this time we obtain a lower NPV that in particular becomes negative. So we have a final result of minus 573. So this means that the value of the project is turned into negative, and so the project is not convenient anymore. So you can easily understand from this example that if I don't modify the operating cash flow, the choice of the appropriate discount rate is critical for the valuation of the project, so for the appraisal of its value, and finally for the decision that I can make about its convenience. Because here, without modifying anything about the cash flows, the only fact that I modify the discount factor will change my judgment about the convenience of the project, and will transform this project from a convenient one to a project that instead is non-convenient and should not be realized. So this means that in practice, when we choose the discount rate, we have to be very careful about the criteria that we adopt in order to determine what the discount rate, what the appropriate discount rate is, because this is important and critical implications for our final decisions on the project. So in this slide, we can show that there is a decreasing relationship between the NPV and the discount factor. This comes by the formula of the NPV, because when R increases, the discount factor for each cash flow decreases. So given the operating cash flows that are not modified, clearly in this case, the net present value will be negatively correlated with R. And in particular, what we can observe, just to generalize the conclusions of our previous example, is that maintaining the same operating cash flow, so without modifying the estimated operating cash flows, we can see that the NPV will be positive until a certain discount rate. So this means that for all the discount rates that are on the left of this intersection point, the NPV will be positive. For all the discount rates that are higher than this discount rate, the NPV will be negative. So this intersection between the NPV curve and the x-axis is a very clear and important meaning that we'll analyze in the next class. And in particular, as we'll see, this intersection point is defined as internal rate of return on the IRR and represent the rate of return of the project. So we'll go more in depth into discussion about the relationship between IRR, discount rate, and NPV in the next class. And this point we can also look at how the NPV can be calculated not only for the total investor but also for the equity holder, so only in the perspective of the equity investment. In particular, we can calculate an indicator that is defined as net present value to equity. And net present value to equity explains project's contribution to the shareholder wealth. So this indicator is useful in the perspective of the shareholders, when the shareholder is deciding to commit a given amount of resources to the project, because the operating cash flows are cash flows that accrue to all the investors. So they represent the total value creation of the project for all the investors, but they don't clearly reflect the value creation for the shareholders, and therefore the shareholders could be interested instead to determine what is the particular value creation that the project generates for them. In this case, we can modify our previous version NPV and calculate what we define here as net present value to equity. Calculating the net present value to equity requires two main changes in the formulation that we saw before about the net present value. The logic is the same. We are always discounting cash flows using the appropriate discount rate. So we are summing up present values of expected cash flows. But here we have two differences in the formula. The first one is that we have net cash flows to equity instead of operating cash flows at time t. So we'll have to pass from operating cash flows to net cash flow to equity. This is something that we have already analyzed when we were talking about the different configurations of cash flows, but now we'll in the next example that we'll make, we'll recall the calculation of of the net cash flow to equity starting from the cash flow for financial planning. The second issue, the second difference as compared to the net present value to the total investment is that here the appropriate discount rate is not discount rate for total investment, but is discount rate of equity. And when we discussed the cost of capital, we have seen that whereas the cost of capital of all the sources of financing is represented by the weighted average cost of capital that accounts for both the cost of debt and equity, the cost of equity is clearly distinct because it's only one component of the weighted average cost of capital. So if we are focusing on the net present value of the shareholders, so the net present value created for equity, we cannot use the weighted average cost of capital to discount the net cash flow to equity, because otherwise we would be accounting also for the expectations of returns of the financiers, of the creditors. So this means that we have to isolate the specific component of the cost of equity. And by the way, this is important because the cost of equity is typically higher than the cost of debt, because we have discussed that equity is riskier. It's a type of investment as compared to debt. So RE will be typically higher than the weighted average cost of capital, and so this is the appropriate discount rate that we have to consider in the calculation of the net present value to equity. But apart these two differences, the formula is equivalent to the formula that we already used for the NPV calculation. Here we have in fact the summation for t going from 0 to n, where n again is the end of the life of the project, of net cash flow to equity at time t, divided by 1 plus RE raised to t, and again this is the discount factor of a cash flow at time t. The difference is that the discount factor is calculated using a different discount rate. So in order to make the calculation net present value to equity clearer, here we provide an example of the calculation. So here we are assuming to evaluate in the perspective of the shareholder a project that has an expected life of 7 years plus an investment made at year 0. So here, in order to calculate the net cash flow to equity, that is what we need for the formula of net present value to equity, we start from the cash flow for financial planning. The cash flow for financial planning is a specific configuration of the cash flow that we have already analyzed when we talk about the cash flow statement, that however is the cash flow that accounts for all the inflows and the outflows of the project, including the equity investment and external finance in the form of new loan and short-term borrowing. And what we see is that in order to have an equilibrium, the cash flow for financial planning is not to be lower than 0, in the sense that the eventual outflow has to be completely compensated by the inflows. So, and in fact, the cash flow for financial planning at year 0 and 1 is equal to 0. This means that there is some kind of initial investment in the project in year 0 and 1 that is covered by new equity investment and new external finance in form of loans and short-term borrowings. Starting from year 2, we have positive cash flows for financial planning that in particular equal to 47 in year 2, 150 in year 3, 200 in year 4, 300 in year 5, 400 in year 6, and 200 in year 7. However, at this point, we have to remember that we are calculating the net cash flow in the perspective of the shareholder. So if the shareholder is investing money into the project to cover the initial investments required from the project, then we have an outflow, because this is money that the shareholders is investing. So the equity investment made by shareholders in the project represent for the shareholder themselves a negative component of their cash flow, because it's cashing going out from their pockets and used for the project. So here we report the two equity investment made by the shareholders in time 0 and 1. In particular, we expect that the equity holders will have to invest 400 in year 0 and 200 in year 1 to cover the financing need of the project. And then we have also to remember that the project is going to pay eventually some dividends to equity holders. So dividends are cash flows that go from the projects to the shareholders. So in the perspective of the shareholders, they are inflows. Remember that we are calculating the cash flows for the shareholders, so we have to account for all the inflows that the shareholders receive and all the outflows that shareholders will have to pay. And in this sense, dividends that are paid to shareholders are present for the shareholders and inflow. So the net cash flow to equity can be calculated by making these two operations, by starting from the cash flow for financial planning, that as we have already said, includes all the inflows and the outflows of the project, and then by subtracting equity investment, and by adding up instead dividends. So the result is here. So the net cash flow to equity will be equal to 400 in year 0, where we have no cash flow for financial planning, and we have an investment made by equity holders of minus 500. Then we have minus 200 in year 1, where again we have no cash flow for financial planning, but we have an investment made in the project of 200 by the shareholders. And then, as you will see, in year 2, 3, 4, and 5, when the project is paying dividends, the net cash flow to equity will be higher to the cash flow for financial planning, because there will be some cash going from the project to the shareholders. In other words, this cash flow for financial planning was originally including for the project an outflow equal to 10, but this outflow equal to 10 in the perspective of the project becomes an inflow of 10 for the shareholders that will receive the dividend that is paid. So we'll have a cash flow to the equity of 57 in year 1, that is equal to the cash flow financial planning of 47 plus 10 of dividend. A cash flow 165 at year 4, that is equal to a cash flow financial planning 150 plus a dividend of 15. Cash flow for financial planning of 200 plus 20 of dividends in year 4 for a total of 220. And so on. So we have a net cash flow to equity of 320 in year 5, a net cash flow to equity of 400 in year 6, and a net cash flow of 200 in year 7. At this point, we have to discount this net cash flow to equity. In this case, as we have seen in the previous formula, and we have explained the reasons for that, we discount this net cash flow to equity using the rate of return of the equity, so the discount rate that accounts for the expectation of return of the equity holder. And in this line, therefore, we obtain the discounted net cash flows to the equity. And at this point, as we did in the previous example, we can just calculate the net present value to equity by summing up all the discounted net cash flow to equity that are in this line. And what we can see is that the net present value to equity here is equal to 111. So this means that in the perspective of the shareholder, the investment that the shareholder is making into the project, that is 400 at year 0 and 200 year 1, is convenient, and that in particular, after considering the initial investment and the following net cash flows, the project is generating for the equity holders a positive value of 111. So the shareholders are receiving a surplus that makes, in their perspective, the project convenient. So at this point, this class is finished. In the next class, we'll look at other dynamic indicators for project value assessment, And I thank you for your attention, and I remind you that, as usual, you can find additional materials about these topics on the course website. Thank you.